So this video is about the gamma function, and I'm just going to go through, there's more to say about the gamma function, but I just wanted to give you a short video because we're short on time. So the gamma function looks like gamma with the alpha parameter is equal to the integral from 0 to infinity z raised to the alpha minus 1 e to the minus z dz. And this is sort of a complicated integral, but its significance is because gamma distributions have that form. The gamma distribution probability mass is equal to 1 over gamma A, beta to the alpha, x, this is an alpha minus 1 e to the minus x to the b. In particular, it's easier to see when alpha is equal to 1, you have here, you have this function, you have the exponential. So the exponential is an example of a gamma function. So the remarkable thing about this integral, this gamma function, comes from the properties of gamma, and that is gamma of 1 is equal to 1, and gamma of alpha is equal to alpha minus 1 times gamma of alpha minus 1. So if this notation looks a little familiar to you, it's because it's very similar to factorial. Because if you recall, when we defined factorial, factorials were defined recursively. N factorial was equal to n times n minus 1 factorial. So essentially, the gamma distribution is a type of factorial, or the gamma function is a type of factorial. The only difference is that the gamma of alpha is equal to alpha minus 1 factorial, whereas our normal factorial, n factorial is just n factorial. Here you have alpha minus 1 factorial, which means, and this is the other thing that's super remarkable, is this integral here, this is a gamma function, is equal to alpha minus 1 factorial. So if you have an integral, something like this, z to the third e to the minus z dx. We can do this by parts. So you learned how to do this in Calculus 2 with integration. But you can also recognize that this is the form of gamma, where alpha is equal to 4. So alpha minus 1 is equal to 3. So then this integral is equal to alpha minus 1, which is 3 factorial. And probably the easiest way to remember is that don't worry so much about the alpha minus 1 and stuff, unless it's in that form. But this exponent here is just what ends up being in the factorial. So as I said, there's more to the gamma function. Often it gets used when you're when you're doing the formula to make a moment generating function, and if you can get your function into this form, then you can use this really nifty kind of shortcut. But since we're short on time, I'm not going to do a lot of examples, but kind of give you just this one easy example.